Have you ever wondered what current and voltage really are? These two concepts are the lifeblood of the intriguing world of electricity, a world that has revolutionized the way we live, work, and play. Electricity powers our cities, fuels our transportation, and even keeps our hearts beating. It's everywhere, yet its core concepts remain a mystery to many. Let's start with current and voltage. Current, akin to the flow of a river, is the movement of electric charge. Voltage, on the other hand, is the force that propels this charge. Together, they form the heart of electrical circuits, powering everything from the smallest microchip to the largest power grid. In this video, we will unravel these concepts, peeling back the layers of complexity to reveal the elegant simplicity beneath. We'll explore how current and voltage interact, their role in everyday devices, and why understanding them matters. Stay tuned as we dive deeper into understanding these fascinating concepts. Imagine a river. The water flowing in the river is similar to electric current in a wire. Let's delve deeper into this analogy. Picture the river as a wire and the water as the electric charge. The movement of the water from one point to another is akin to the flow of electric charge, or what we call the electric current. Just as water flows from a higher level to a lower level, electric charge flows from a point of higher electric potential to a point of lower potential. The force that drives this flow of water or charge is due to a difference in potential energy. In the case of electricity, this difference is called voltage, but we'll get to that later. Now, just as the volume of water flowing through the river per second can vary, so too can the amount of electric charge flowing through the wire. This is where we get into the concept of the current's strength. The larger the volume of charge flowing per second, the stronger the current. And how do we measure this current? We measure it in units called amperes, named after the French physicist André-Marie Ampère, one of the main founders of the science of classical electromagnetism. So remember, current is all about the flow of charge, much like water flowing in a river. It's a fascinating world, isn't it? Now, let's move on to the next part of our journey, the enigma of voltage. Now think about a water pump that pushes the water through the pipes. This analogy is a great way to grasp the concept of voltage. Just like the pump provides the force to move water, voltage provides the force, or push, to move electric charge, which we call current, through a circuit. Imagine a water pipe system. The pump, with its mechanical energy, pushes the water from one point to another. Similarly, in an electrical circuit, voltage acts as that pump. It's the energy source that propels the electric charge from one point to another, causing it to flow through the circuit. The strength of this push is what we measure as voltage. The more voltage, the stronger the push, and the more current will flow. This is why you'll often hear people refer to voltage as electric potential difference. It's the difference in electric potential energy between 2 points that drives the current. And just like we measure the water pressure in pascals or psi, we measure voltage in volts, named after the Italian physicist Alessandro Volta, who invented the voltaic pile, the precursor to our modern batteries. So, when you look at a battery and see it rated at, say, 9 volts, that's telling you how much push it can give to the current in a circuit. So, voltage is the push that moves the charge along the circuit, similar to how a pump pushes water through pipes. It's the driving force that makes our electronic devices work, from the smallest watch to the largest supercomputer. We've delved into the fascinating world of current and voltage, but what are the key takeaways? Let's take a quick detour down memory lane. We've discovered that current is pretty much like a river. It's the flow of electric charge. It's the electrons in motion, moving from one place to another. Now, what gets these electrons moving? That's where voltage comes in. Voltage is the electrical force that propels this charge. It's like a pump pushing water. Without voltage, there's no current. Just like without a pump, there's no flow of water. Getting a handle on these concepts is crucial for anyone looking to get a basic grasp of electricity. It's like understanding the ABCs before diving into literature. So next time you switch on a light or charge your phone, remember the invisible forces at work: current and voltage. Understanding them helps us appreciate the magic of electricity even more.